Today we are using the trigonometry we learned yesterday and applying it to applications, sort of. A few applications, not too many. We're doing two different things today, and they both involve use of the calculator. In fact, you have to use the calculator to get the answers. Yesterday, we learned our right triangle trig. What was our mnemonic device to help us remember our trigonometry ratios? SOHCAHTOA. SOHCAHTOA. Write that down. Oops, I did it wrong. Because I can't talk and write, evidently. SOHCAHTOA. T-O-A. SOHCAHTOA. Make sure you're writing this down on the top of your paper. Again, today, you're going to have to use it. And today, what we're really looking at is if we're given information of a triangle, can we write a sine equation? Can we write a cosine equation? Or can we write a tangent equation? And then use that to solve for whatever's missing. Okay? And so we have three possibilities today. Whether or not we have information about the sine, we have the opposite side of the hypotenuse, that sort of thing. So we're looking for what information we've been given today. So let's see here. Example 1. Find the missing side labeled X. So this is a right triangle. I do want you to draw the triangle. It is really important. Find the missing side. So in these, we are finding the side length of a triangle. So this is really important that we understand we're looking for the side length. We have this angle here is marked as a 32-degree angle in the triangle. And we have a side length X that we're trying to find, and we have this lower side that's labeled 14 feet. So again, I'm going to write down my SOHCAHTOA at the top of the page because, again, it's going to be super useful for us. So SOHCAHTOA. And what these are little miniature equations, really. We have three little equations. And let's see what we've got here. So looking at this triangle, I have this 32-degree angle. And if I'm looking from this 32-degree angle, what label can we assign this side length X? Hypotenuse. Yeah, this is the hypotenuse. How do we know it's the hypotenuse? Opposite from the 90-degree angle. Perfect. So we know that that's the hypotenuse. If this is our 32-degree angle we're looking from, what label does the 14 feet get? Is it the opposite or the adjacent side? The adjacent, yeah. So this is the adjacent side because opposite the 32 is over here. This is the opposite side, that one. We don't have information about the opposite side. We have the adjacent and the hypotenuse. Which trig function could we set up if we have adjacent and hypotenuse? Cosine. This cosine ratio uses adjacent and hypotenuse. So that's the one that we're going to set up. This little equation that says the cosine of some angle, in this case it's our 32-degree angle, is adjacent over hypotenuse. So 14 feet over x feet. And this is how we get to set it up. Cosine of some angle, there always must be an angle there, is adjacent over hypotenuse. Pretty easy to do. Now, we need to isolate x, and so we're going to manipulate this equation. I'm going to go ahead and start by multiplying both sides by x. So I have x times the cosine of 32 degrees equals 14. And then how do we get x by itself? Divide by Cosine of 32. Yeah, we want the x alone, so we need to get rid of the cosine of 32 degrees. So we're going to divide by the cosine of 32 degrees, and that's going to allow us to solve for x, which is something we're going to type into our calculator very carefully, cosine of 32 degrees, and this is going to go into our calculator. So first of all, your calculators are set in default mode to radian mode, which we're going to talk about later. We have to tell them it's degrees. How do I know it's degrees? Got the degree symbol right there. It's really, really important. Okay, so here we go. If you have a TI out, we are going to type in, and you need to practice this. I need to see hands on calculators. 14 divided by the cosine of 32, but we need to tell it degrees. Otherwise, you're going to get the wrong answer. And so to tell it degrees, you see there's this angle option here, right there. It's in blue, so we're going to do second angle, and degrees is the first one, number 1. So we can add on that 32 degree bubble, and that's really important that you tell the calculator you're in degrees. And we get 16.5, and I'm going to round to the hundredths place, so 16.51. On the Casio, I'm in the main math menu, and we're going to do a similar thing, 14 divided by cosine of, so I need to put in my parentheses there, 32. Now, our menu, once we find them in degrees, it's actually much easier. So what we're going to do is we're going to press Option, and then we have the More option. So if you move over to More, and then you see angle right here. And I'm going to choose F5. And degrees is that first dot there, F1. So once you find it, it'll stay there. So that's really quite nice. Do I need to do that again? No? Got it? Okay. So that option and angle is the way to go there. And you can see that we get, again, 16.51. We're rounding to the hundredths place, okay? So we do have to tell the calculator we are in degrees. That is really important. But that is the length of that hypotenuse in that 14-foot triangle. Okay. All right, let's look at this letter B here, this crazy looking upside down and swiveled triangle. Do you have a right angle up there? We have this 22-degree angle that we've been given information on. I have a side length of 25 inches and then our side length x. And so we need to figure out the labels for these sides. So if I'm looking from my 22-degree angle, what side length or what label does x get? Opposite, yeah. It is the side opposite our 22-degree angle. Which means 25 is what? Adjacent, yeah. And we know it's the adjacent because this one has to be the hypotenuse opposite the right angle, okay? So we have information. We have a 22-degree angle, and we have the opposite side and the adjacent side. So looking at my SOHCAHTOA here, which one involves opposite and adjacent? Tangent, yeah. So we're going to use the tangent ratio. So the tangent of our 22-degree angle is opposite over adjacent. So opposite over adjacent would be x over 25 inches. Now, this one's easier. Our job is to isolate x. What do we need to do? Multiply by 25. Yeah, x, we just need to get rid of the 25. So we're just going to times both sides by 25. And so we get x equals, and all this, 25 times the tangent of 22 degrees, we can put in our calculators. So let's do that. Let's see, give me some good. Okay, so 25 times the tangent of 22, and I need, how do I get the degree thing? Yeah, a second angle. So we do second angle, and then it's number 1 right there. So 10.1. 10.1, in this case, inches. I'm going to do it on my Casio just so we can make sure we're seeing that again. And again, my menu is still up, so that's actually really nice on a Casio. God, I really love the Casio. Have I said that enough? It's only 2 degrees. So the degree button is still there. Once you access it, it stays, so that's really nice, the degree menu. Option angle for Casio. Okay, so these are pretty easy. Questions on these? Finding side lengths. Very easy. Good? Good, good? Okay. Last thing. Example 2. Find the measure of the labeled angle. So the last problems we were finding side lengths, and now we're finding angles. The labeled angle, in this case, it has a label of L, so it's talking about this angle right here with the letter L. And on this picture, we're looking for the angle M here. And they're marked with little arc marks on your worksheet today, just like that, and letters. And again, we have a right triangle. Very important to do right triangle trig. We need to have a right triangle. So they do have little right angles in them. Very important. And again, we're still using our SOHCAHTOA. So I'm going to write that up top of my page again. SOHCAHTOA. And again, these are little equations that we are going to decide which one suits us for this particular triangle. SOHCAHTOA. Those are equal signs if you can't tell that. All right, here we go. So finding the measure of the labeled angle. We're trying to find angle measures now. So a little bit different. But let's see. We're looking from this angle L right here. And if we're looking from angle L, what information... What label can we give the 40? Hypotenuse, absolutely. Definitely want to do that one first. Is the hypotenuse because it's opposite the right angle? Okay. And if we're looking from angle L, what would the 25 label be? Opposite, yeah. All right. So that's the opposite side. And so now we have information about the opposite and the hypotenuse. Which trig function can we apply here? Sine, opposite over hypotenuse. So we can do that. That would be the sine of some angle. What angle is it? L, yeah, the sine of angle L. Crud. Okay. I just had an aha moment here. Whoops daisy. Okay, I have to figure out how to do something else now. The sine according to angle L is opposite over hypotenuse. So 25 over 40. Okay, our job is to figure out the measure of angle L. And to do that, right now, it's trapped inside a sine function. And the only way, and we haven't done this before, but the only way to get rid of a sine function, we can't divide by sine. It doesn't work like that. It's a function in itself. The only way to undo a sine function is to take its inverse. So that is sine inverse. This is inverse. Inverses undo one another. And so we take a sine inverse of both sides. Sine inverse of a sine cancels itself out and frees the angle L. And then in our calculators, we can type in sine inverse of 25 over 40. But now I have a little issue that I didn't think about before this moment. So we're going to do a whole mode change here. Instead of having to do the little degree symbol, will you please, on your TIs, go to mode right here. Click on mode. And we're just going to go ahead and change our mode to degree mode. So you can see it right there. Hit enter to highlight degrees. You need to do this on your calculator if you want to get the right answers. Okay? And now you can disregard the whole degree symbol thing. Your calculator's in degree mode. Okay? And this will give us degrees answers. On the Casio, I'm going to have to take a second to figure this out, but maybe it's under setup. So you see it as a shift setup and mode. Oh, angle. There it is. So under setup, you see angle, and we are in radian mode. We want to change that to degree, which is F1. So we're going to hit F1. And now it's in degree mode, and we can exit. Okay, now we'll always get degree answers. So we can disregard the little degree bubble that we need. So you can forget about it now. That's kind of nice. I should have done that earlier. So now we get to type in. You can see sine inverse is right above the sine button. It's a second function. So you're going to do second sine inverse of 25 divided by 40. And on the Casio, very similarly, we're going to do shift sine inverse of 25 divided by 40. And hit enter, and we get an angle L measure of 38 point, I'm going to round to the 10th place, 7 degrees. And it's degrees because we're in degree mode. There's a whole nother mode that we could select that we'll learn about next week, but for now we're in degrees. And I think what happens on the worksheet today is you find your angle degree measure answer, and then you put the letter in the box. Okay, so you'd put the L where you find the answer. One more here. Let's see, we've got angle M. Let's assign some labels here. If we're looking from angle M, what label do we get to give the 10 centimeters? Opposite, yeah. This is the opposite side, which means 12 would be what? Adjacent. Good. This one over here, opposite the right angle, is the hypotenuse. So we don't have any info there, so we're not going to use it. Which trig function involves the adjacent and opposite sides? Tangent. So we're going to set up a tangent equation. So the tangent of some angle, what angle? The tangent, according to angle M, is opposite over adjacent. So 10 over 12. And again, our angle M is trapped right now. It's trapped inside a tangent function. How do we cancel out a tangent function? Inverse tangent, yes. So we're going to take a tangent inverse. Not tangent to the negative 1. Say tangent inverse of both sides. Tangent inverse of both sides. Tangent inverse and tangent undo one another magically. And we get angle M is the tangent inverse of 10 over 12. 12, which we can then plug in our calculators very easily. Okay. So tangent inverse is above the tangent function. So we're going to do second or shift tangent inverse of 10 over 12. And we get 39.8 degrees. Okie dokie. Do you have any questions for me? Do you always use an inverse function? No. When do we use an inverse function? When you have an angle that's trapped and you're trying to find the angle, okay? Side lengths are easy. Angles have the inverse function usage. okay? All right, ladies and gentlemen, today's so easy, and there's not a lot of math to show, like you can, because it's mostly calculator work. And so what I want to see is your lovely setup. I want to see your setup, your trig equation setup for these. And again, most of it is calculator work, but if I see that trig setup, you're good to go. So that's what I need to see on the paper, and the rest of it pretty much you can do with the calculator and get it done pretty quick, okay? So I do want to see that initial equation setup, but other than that, it goes really, really fast, okay? All right, let me stop this.